Imagine, for a moment, the perfect universe. What would it look like? Every star shining forever, a brilliant cosmic city that never sleeps, neat, orderly spiral galaxies spinning in perfect harmony with neighbors, planets teeming with life, each a paradise garden filled with incredible creatures. The laws of physics would be simple, elegant, completely understandable, built with the precision of a master watchmaker, gears turning without friction, time flowing smoothly, forever. The universe we imagine, this idealized vision is comforting, isn't it? Our journey into the universe's imperfections begins with a simple, yet profound, observation. The night sky isn't uniformly bright. If the universe were infinite, if it were eternal, if it were filled with stars in every direction, then no matter where you looked, your line of sight would eventually land on a star. The entire sky should be ablaze with light, as bright as the surface of the sun. This puzzle is called Olber's paradox. The darkness of the night sky is itself a sign that the simple model of a perfect, eternal cosmos is wrong. The darkness tells a story about the universe's history and limits. First, the universe is not infinitely old. It had a beginning, the Big Bang, about 13.8 billion years ago. Light from beyond that time hasn't had time to reach us. There's a cosmic horizon, a limit to what we can see. Second, the universe is expanding. Space between galaxies is stretching like a rubber sheet being pulled. The cracks in the cosmic egg open the door to a stranger universe. The quiet darkness of night screams a loud message about reality. Just when we thought we were getting a handle on the universe's expansion, we discovered something truly bizarre. For decades, astronomers assumed that the expansion must be slowing down. After all, gravity is the dominant force on cosmic scales. Every galaxy, star, and dust cloud is pulling on every other one. It's like throwing a ball into the air. You expect it to slow down and eventually, perhaps, fall back down. Scientists were trying to measure just how much the expansion was slowing, but in 1998, two separate teams of astronomers studying distant supernovae found the exact opposite. The expansion of the universe is not slowing down, it's speeding up. It's as if you threw a ball into the air and instead of slowing, it suddenly accelerated. Let that sink in. To explain this cosmic acceleration, scientists had to propose the existence of a mysterious repulsive force. We call this force dark energy. We call it dark because we have absolutely no idea what it is. Dark energy is perhaps the biggest imperfection, the biggest glitch, in our understanding of the universe. It currently makes up about 68% of the total energy density of the universe. More than 2/3 of the cosmos is made of something we can't see, we can't detect, and we can't explain. It's a cosmic ghost that is overpowering gravity. When we look at maps of the universe, we see a beautiful, intricate structure. It's often called the cosmic web. We see vast filaments of galaxies, superclusters where thousands of galaxies are packed together, great walls of matter stretching for hundreds of millions of light years. But this picture is deceiving because it focuses on where the matter is. The most dominant feature of the universe's large-scale structure is the vast, terrifyingly empty spaces, the cosmic voids. These voids are not just slightly empty regions, they are staggeringly barren. They are immense bubbles of nothingness, hundreds of millions of light-years across, containing very few, if any, galaxies. While a supercluster might be a bustling cosmic metropolis, a void is a desolate cosmic desert. If the Milky Way were in the middle of a large void, we wouldn't have known other galaxies existed until the 1960s. The night sky would be almost completely dark, devoid of the faint smudges of our galactic neighbors. These voids make up the vast majority of the volume of the universe. The cosmic web is just the delicate foam on the surface of enormous bubbles of emptiness. It's another imperfection, another piece of the puzzle that doesn't quite fit. In a perfect universe, perhaps matter and energy would be eternal. But our universe has a flaw, a feature so extreme it breaks the very laws of physics as we know them. I'm talking about black holes. These are not just science fiction monsters, they are real. The ultimate cosmic imperfections. A black hole is what's left behind when a massive star dies and its core collapses under its own gravity. It collapses so completely that it squeezes an immense amount of mass into an infinitesimally small point, a singularity. This creates a gravitational field so powerful that nothing, not even light, can escape. Black holes are the universe's ultimate dead end. They are one-way doors. Anything that crosses the event horizon, the point of no return, is lost to the rest of the universe forever. Information, matter, energy, it all goes in and nothing comes out. This violates one of the most fundamental principles of physics, which suggests that information can never be truly destroyed. Einstein's theory of gravity, general relativity, and quantum mechanics clash here. They are a place where our understanding of reality literally breaks down. We now know these cosmic monsters are not rare. Supermassive black holes lurk at the center of nearly every large galaxy, including our Milky Way. Millions or even billions of times the mass of our Sun. They are active and violent. They gobble up stars and gas clouds, unleashing incredible bursts of energy. They can affect the evolution of their entire host galaxy. They are both anchors and chaotic engines, scars left behind by the chaotic life and death of stars. There is a law in our universe, perhaps the most fundamental law of all, that speaks to its ultimate imperfection. It's the second law of thermodynamics. Everything tends towards disorder. Think of your bedroom. It's easy for it to get messy, high entropy. But it takes a lot of work to make it neat and tidy. This concept is called entropy. The universe started in a very hot, dense, low entropy state at the Big Bang. Ever since then, it has been on a one-way journey towards maximum entropy, maximum disorder. This relentless march of entropy is the ultimate source of all decay and death in the cosmos. Stars are not eternal beacons of light. Every star you see in the night sky is on a countdown to extinction. They shine by converting highly ordered fuel like hydrogen into less ordered energy and heavier elements. Eventually, they run out of this fuel. They die, often spectacularly, leaving behind remnants. This leads to a grim prediction for the ultimate fate of the universe: heat death. In the far, far future, after all the stars have burned out and black holes evaporated, what will be left? The universe will be a cold, dark, and empty place, filled with a thin soup of elementary particles at a uniform temperature, close to absolute zero. In this final state, no work can be done, no complexity can arise. There will be no stars, no planets, no life. Only a vast, silent, unchanging darkness. It's a magnificent, complex structure that is slowly, inevitably falling apart. Perhaps the most personal and poignant imperfection of the universe is the profound silence we are met with when we ask, "Is anybody out there?" Given the sheer number of stars and planets, we might expect the universe to be teeming with life. Our galaxy alone contains hundreds of billions of stars, and there are hundreds of billions of galaxies. The number of potentially habitable planets is staggering, likely numbering in the trillions. In a perfect universe designed for life, we would expect to find cosmic neighbors everywhere we look. The sky should be filled with signals, yet we find nothing. Absolute silence. This is the Fermi paradox. If life is common, where is everybody? Despite decades of searching for extraterrestrial intelligence, we have not found a single credible signal. We scan the skies and hear only the quiet hiss of the cosmos. This could mean that the emergence of life, especially intelligent life, is an incredibly rare event. The chain of events that led from the Big Bang to bacteria to beings who can contemplate the cosmos might be so fantastically improbable that it has happened only once here on Earth. The universe is full of radiation, asteroid impacts, and violent stellar events. It's a dangerous place. Life, it seems, is not the goal of the universe. It's a fragile, accidental byproduct that clings to existence in a few sheltered corners. You need a stable star of the right type. A planet in the Goldilocks zone, a protective magnetic field, a stable climate over billions of years, and 1,000 other factors. And even then, the jump from chemistry to the first living cell might be almost insurmountable. This makes our existence on this small blue planet both incredibly precious and incredibly lonely. We are the universe's way of knowing itself, a tiny flicker of awareness in an ocean of unthinking matter and energy. The discovery of these cosmic imperfections was not a single eureka moment. It was a slow, painstaking process of observation, deduction, and the relentless challenging of old ideas. For centuries we held on to the idea of a perfect clockwork cosmos. When Galileo pointed his telescope at the heavens, he saw the moon was not perfect and the sun had spots, shattering celestial perfection. In the 20th century, Edwin Hubble proved that the faint spiral nebulae were other galaxies far beyond our own. By studying their light, he discovered they were all moving away from us, the farther the faster. This was concrete evidence for the expansion of the universe. That paved the way for the Big Bang theory. As our tools got better, the universe started revealing its strange and messy secrets. Dark energy was discovered by using distant exploding stars as standard candles, measuring brightness and redshift. Cosmic voids were mapped through massive galaxy surveys like the Sloan Digital Sky Survey, recording positions and distances of millions of galaxies. Building a three-dimensional map of the universe's structure revealed the cosmic web and its vast emptiness. Black holes were first theoretical predictions, but we now have direct evidence, like the first image of a black hole's shadow. And LIGO detected gravitational waves from merging black holes, opening a new window. Each discovery required us to build bigger, better, and more sensitive eyes and ears. It took the careful work of dozens, sometimes hundreds, of scientists to confirm mind-bending results. We peeled back layers of cosmic reality and confronted its beautiful, baffling imperfections. Each new instrument and survey pulls back the curtain a little further. So, we find ourselves in a universe that is not the perfect, eternal machine we once imagined. It's a cosmos expanding at an accelerating rate due to a mysterious dark energy we don't understand. Its matter is arranged in a clumpy, web-like structure separated by vast voids. It contains monstrous black holes that break the laws of physics and gobble up matter and light. It is governed by a fundamental law of increasing disorder that guarantees its eventual decay into a cold, dark nothingness. And in all this vast, chaotic, and indifferent space, life and consciousness appear to be almost impossibly rare. Does this knowledge make the universe a lesser place? Does it diminish its majesty? I would argue the opposite. This beautifully broken cosmos is infinitely more fascinating than a perfect one could ever be. What is dark energy? What is dark matter? What happens inside a black hole? Are we truly alone? These questions are the lifeblood of human inquiry. They ignite curiosity and fuel the scientific enterprise. The imperfections of the universe should also inspire humility and wonder. We are not the center of a grand, orderly design built for our benefit. We are the product of cosmic chance, a fragile speck in a wild and untamed wilderness. This realization connects us to the cosmos in a more profound way. We are not just observers, we are part of its strange, ongoing story. The quest to understand its flaws is the greatest adventure of all. We are a fleeting moment of order and consciousness in a system that trends towards chaos. That makes our ability to understand even a small part of this story truly remarkable. So the next time you look up at the night sky, don't just see the perfect twinkling stars, see the whole story. Embrace the weirdness. Stay curious.